对向量来讲的话，有第二种的这个乘法，第二种乘法叫做 vector or cross product. Okay, and unlike the dot product, once you do this multiplication of these two vectors, it's also a vector. So there's a direction and also magnitude associated with it. Okay, and the vector product, the cross product basically is the multiplication of the two vectors, two magnitude, and then multiply with sine with the angle between these two vectors. So AB sine theta is going to be theta AB is going to be the magnitude of this vector cross product. It turns out that there's a physical meaning of this. Well, basically AB sine theta AB is the area of this paragraph. Okay, 这个平行四边形的面积。So if theta AB is equal to 0, this means that there's no area. So the multiplication cross product will give you 0. So if you have two vectors, they are aligned along the same direction, you don't get any magnitude for this vector cross product. So in some sense, it's a measure of how perpendicular the two vector is. Okay, 它是 in some sense 它是让你知道就是这两个 vector 多么的互相垂直，不像刚刚的那个vector 的 dot product. It tells you how parallel the two vectors are. Okay, 所以这是两不同的这个 vector product. But the direction for the vector cross product follow the right-hand rule. Okay, if you do a cross B, then you allow your four fingers to follow the direction of A, and then move your finger toward the direction of B. Then your thumb, the direction of your thumb is going to be the direction of A cross B. Okay, so this is the right-hand rule. You knew it long time ago. 这个你注意到这个 vector 的 cross product is not commutative. Okay, A cross B it is different from B cross A because the sense of the direction is reversed. So you have to put a minus sign in front of it. Okay, that is because of the sense of direction has been reversed. 所以呢，你注意到这个 A cross B cross C is not equal to this expression because when you put a parenthesis on it, this means that you do this first. But if you do this B cross C first, you're not going to get the same value as the A cross B cross C with this perform first. Okay, 你如果先做这个的话，跟先做这个结果的答案是不一样的。So be careful about this. Okay, and now that we know this is the area, there's a way to calculate the volume. For example, if you want to calculate the volume of this, well, the first step is to calculate the area of this, and then do a dot product with C to get the volume of this box. Okay, so the volume is conserved no matter you calculate the area of A cross B first or B cross C first. So basically, these three expressions all calculate the volume of this box. Okay, you can calculate the area of formed by AB first, or you can calculate the area expanded by BC first, or you can calculate the area expanded by CA first. Okay, and then this dot product basically just tell you the height along some direction for this box. 所以呢，这三个式子基本上都在算这个体积的大小。OK， 那体积的话呢，我们以前学过，就是底面积乘上那个高 ，right？ 这 dot product 基本上就是告诉你这个高沿的这个 A cross B 的方向的这个高 的大小是多少 ？Because dot product is a projection of C along some reference direction, and this reference direction for this case is the direction produced by A cross B。OK， 所以呢，你学会了这个 dot product 跟 cross product 之后呢，你就学会了开始算面积跟体积了。Okay, I always want to connect mathematics to some physical concept. Okay, 就像你学这个vector calculus 的话，你必须了解到你要做很多的 flux 的计算或者是 circulation 计算。同样的，这个 the purpose of this cross product and dot product can help you to calculate the area and also the volume. Okay, now whenever you deal with a problem, you want to first create some coordinate. Okay, 那对你来说最简单的这个 coordinate system is a Cartesian coordinate system with some rectangular symmetry. 你最习惯的就是 x y z 直角坐标系统 ，right？ 这个叫做 Cartesian coordinate system. And in this coordinate system, you create 3 unit vectors along x direction, y direction, and z direction. And with unit vectors denoted by this A sub x hat and A sub y hat and A sub z hat. And a vector inside this Cartesian coordinate system or rectangular coordinate system is that you have 3 components. One is along x direction. One is along y direction, and the third one is along z direction. And you saw this in the video already. Okay, and the x, y, z coordinate system are perpendicular to each other. Therefore, you can do a cross product of the two to generate the third one. Because this cross product tells you how perpendicular the 2 vectors are. So when you do cross product of AX cross with AY, the sine theta AB in the last page is going to be equal to 1 because theta AB, theta XY is 90 degree. Sine 的90度呢，基本上跟你1，所以呢，你得到这个 AZ. But if you do AY cross with AX, then you have to reverse the direction. Okay, this is going to be equal to AZ, but there's a minus sign in front of it. Okay, so you have to follow the right-hand rule to do the calculation. Well, the same thing, the unit vector along the x direction can be generated from the cross product of AY and AZ. Okay, and again, the AY can be generated from the cross product of AZ and AX. And this is simple enough, right? This is sort of for this example, you have AY, AX, and then sine theta YX. And you have 1 for this, 1 for this, and this is minus 1. And the whole direction is along z direction. So this is a very simple construction for these 3 relationships. And for the dot product, and again, the physical meaning for the dot product is to tell you how parallel the 2 vectors are. 所以呢，在直角坐标系里头呢，这两的这个方向呢是互相垂直的，所以呢，它完全不平行。所以 no wonder that if you do a dot product for any 2 of the unit vectors will give you 0, 因为它非常的不平行，两个是互相垂直的 ，OK， 是平行的另外一个极端，所以呢 you get 0. Again, I want to remind you the very important calculation for field is flux and circulation. For circulation, you always have to deal with the integration of length. So let's pick up the differential length in space in XYZ coordinate system, in this rectangular coordinate system. The differential length in this system is that you pick up a small differential length in x direction and you give it a direction along x, and then you pick up the differential length along y. That is along the y direction, so you have this unit vector here, and then you pick up the small direction along z. OK， 所以一小段这个距离呢，在 x、y、z coordinate system 它向量的表示法就是这么简单。OK， 那这个基本上所代表就是一个小长度在 x 方向，那这个表示法是一个小长度在 y 方向，这个一个小长度在 z 方向。Well, once you have the length, then you can construct area. 每一个面，它来自，比如说 dx 两个线段所组成的。And then, in vector calculus, a surface has a direction. 每个面都有方向，为什么？这个是来自你的 vector cross product, right? When you do this, the vector cross product, you are calculating some area with some direction. It's a vector. So every surface has a direction. Okay, a surface is a vector. So let's construct a differential surface in space. This differential surface is a summation of three vector surfaces. One along x direction, one along y direction, one along z direction. Okay, and the one along x direction basically is expanded by the cross product of the two differential lengths along y and z direction. Okay, 所以在 x 方向上头的一个小面积，它是来自这两个小长度的 cross product, and then dl cross with dy give you a surface along z direction. Okay, so you construct a sz that is equal to dl x cross with dly. The same thing, you can construct the differential surface along x direction, differential surface along y direction, and so on. OK， 所以呢，你注意到这个面积是有方向的。在 vector calculus 里头呢，没有方向的是什么？是体积，体积没有方向。And previously, I just told you that the way to calculate volume is through this expression, cross product and then a dot product. Okay, so for a differential volume, this differential volume is dx, dy, dz, and this can be constructed from the cross product of the length and then dot product with the third length. Or, in fact, this is equal to ds z with dlz. Okay, this is dsy with dot with dly. Or this can be also dsx dot with dlx. The same thing. Okay, 这三个。这是 x、y、z 的坐标系统，你要熟悉它的脉络，因为底下我们要讲到 Cylindrical Coordinate System and Spherical Coordinate System. OK， 所以呢，这个小体积是来自3小段长度乘的结果。以这个向量的表示法呢，基本上你先算出它的底，再乘上它的高。OK。Now, so the vector dot product A dot B is going to be like this. Okay, A dot B, previously you have A with 3 components, AX plus BX, no. You have AY plus AZ, and then you have B equal to bx by ay plus bz az, and then you do a dot product for these two vectors. 在这里头呢，上头3项，底下3项，总共 dot product 下来有9项。Okay, but if you do a cross product, if you do a dot product for cross terms, ax dot with ay give you 0. So for any cross terms will give you nothing. Only those ax dot with ax will give you the value of ax and bx right here. Okay, and the dot product of this term with this term will give you the second term ay by, and the dot product of az bz is going to give you this term. Okay, and don't forget that the vector dot product is going to give you a scalar, not a vector. Okay, 那这是只剩下9项，只剩下3项，是因为这个 cross term 都消失掉，因为这个关系。And for vector cross product, then it's represented by this, and you know about this long time ago. Okay, 那这是最简单的 x, y, z coordinate system. The next coordinate system is a little bit complicated, but it's useful to solving the problems with the cylindrical symmetry. So let's take a look. So this is a cylindrical coordinate system. For any problems with this kind of symmetry, it's easier to use a cylindrical coordinate system to solve it. For example, if I have a transmission line, I have a waveguide that has a geometry of cylinder. All right, and then now you use a cylindrical coordinate system to solve it. So again, we have to define the 3 directions that describe this cylindrical symmetry. And the 3 directions are r, small r, and phi, and z. Along this axial direction is the direction of z. Okay, r 的方向基本上就是这个径向，这个半径的方向叫做 r. 然后呢，if you project this onto the xy plane, then the angle between x and this projected line r is called phi. So this is phi is a so-called azimuthal angle, reference to the x-axis of the x-y-z coordinate system. OK， 所以这个呢，应该是你高中的时候也学过了。OK， 那跟之前一样，我 r phi z 这3个方向都互相垂直的。都是互相垂直，所以呢，在这个 cylindrical coordinate system 上头，一个 in general a vector is expanded by the 3 unit vectors r phi z. OK， 然后呢，一样，它的 dot product 跟 cross product is going to give you this orthogonality property, because r phi is perpendicular to each other. Therefore, you have something. If you do a cross product for AR crossed with A phi, then you generate a unit vector along z direction. Okay, and because all 3 vectors are perpendicular to each other, therefore their dot product, 两的这个 dot product give you nothing. Okay, and again, this dot product is a measure of how parallel 2 vectors are. Because all 3 vectors are perpendicular to each other, so the dot product give you 0. Now, with this definition of the coordinate system, we are ready to describe the length, the surface, and the volume. 有了这个定义的坐标之后呢，我们就可以在上头取一小段长度。能够取一小段长度，我们就可以取一小个面积。能够取一小个面积，我们就可以去算它的体积。Okay, so r phi z along r direction, of course, the differential length is dr along r direction. The differential length along z is dz. That is understood, right? But the differential length along phi direction, that is this a small length along this circle, it's going to be, well, the length from here to here is r, and a small section on this circle is going to be dr, r, the radius multiplied with the differential angle d phi. OK， 所以在这坐标系里头呢 ，you have to pay attention to dl phi along phi direction. That is equal to the radius multiplied with the differential angle d phi. Okay, once you understand this, then you are ready to calculate the differential surface. 每个这个面的话呢是两个小短线的 cross product. Okay, so if you write down the vector for the differential surface, well, it contains three directions, r, phi, z, three directions, and every direction has a small surface. Okay, if you are interested in the surface along r direction, that is 这个 surface 呢是朝向 r 的方向的话，那朝向 r 的方向的这个面是哪个面？是这个面。这个面呢有两个长度，在这个方向是 dz， 这个面呢是 r d phi， 这个长度是 r d phi。Therefore, the surface area is r d phi multiplied with dz, and the direction is pointing toward r direction. 所以呢，第一项在这里，你这个dl phi 是这个长度。然后 dlz 是这个长度，所以你把它算出来。er along r direction, you have a small surface that is equal to dl phi cross with dlz. 这个算出来呢 ，again along r direction, but dl phi is r d phi, dlz is dz. Okay, so this is the differential length, a differential surface along r direction. Okay, so you can do the same thing for the differential surface along phi direction, differential surface along z direction, and then you have a vector, a general vector for the differential surface in this coordinate system. Once you have the surface, you have length, then you are in the position to calculate the volume of this differential volume. You can pick up any surface and multiply with the height to get this volume. So you have three possible expressions to show this volume. OK， 所以你有三个式子可以算这个体积。刚刚我们在介绍这个cross product, dot product 的时候已经给你了。Right, basically you get r dr, d phi, dz, and r d phi is l phi, dr is lr, dz is lz. 所以三段小的这个线段乘起来之后，就给你一个小的 volume。OK， 然后呢，我们要学会就是在这个坐标系统里头怎么去算它的 dot product and cross product. Okay, so basically the dot product gives you very similar expression in the rectangular coordinate system. Basically, all the cross terms disappear because of this orthogonality property of the three unit vectors. And for the cross product, again, you use this matrix to represent A cross B. 有问题？再来的话呢，是圆坐标，圆坐标一样，也是一样 decompose the three orthogonal directions into three unit vectors. And basically, you just follow the same steps to derive the differential length, differential surface, and differential volume. OK， 所以这个是圆坐标， 圆周标里头呢3个方向 ，one is along the radial direction that is denoted by capital R。所以呢，圆周标里头，这个在 XYZ coordinate system 里头呢，有个圆。And along R direction, for example, if we look into this point right here, along R direction, you can define a unit vector A sub capital R. And then theta is the angle between the polar axis all the way down to this line. Okay, and this is called the collateral angle theta. The maximum collateral angle is pi. 就从这里到最底下来的话就是 pi， 不是2派。Okay, and then if we project this line onto the xy plane, and then the angle formed between this projected line and x is phi. Again, it's a azimuthal angle. 这是圆坐标。我想这个也是在你高中的时候都学过了 ，right? R theta phi 的定义。And so in general, in this spherical coordinate system, you have 3 components, one along capital R, the radial direction, one is along theta direction, okay, 朝下, and then A phi is defined similar to the direction defined in the cylindrical coordinate system, 跟圆柱坐标里头的这个定义是一样的。然后这3个方向呢互相垂直。所以呢，讲了这个 rectangular coordinate system 跟 cylindrical coordinate system 之后，其实 you can easily extend the concept to the spherical coordinate system, because while if we talk about orthogonality, then you construct a very similar relationship for the 3 unit vectors. All right, basically it tells you that all 3 vectors, unit vectors, are perpendicular to each other. But don't forget that if you change the order of the multiplication, you change the sense of the direction. 譬如说，这里如果是 A theta cross with AR， 你这里要加一个负号 ，OK， 所以它是有顺序的。那你要记得这个顺序是 R theta phi, right? R cross with AR cross with A theta give you A phi, but if you reverse the order, A theta cross with AR, then you have minus A phi. OK， 所以这些都是给你复习，从高中时候就学的。Again, once you define the coordinate system with unit vectors, then you can start to construct the differential length. 所以一个 differential length 同样的有3个 component AR, A theta, A phi. 那 the differential length along R direction definitely is dr, right? 在这一小线上的这个长度的话，基本上就是一小段的 dr. 那在这个 theta 方向上的长度这一段 ，OK， 这一段长度的话，基本上就 dr 乘上一个r。一个 r 乘上一个 d theta， 一个 differential angle， 来这一段，因为这里的角度是 theta， 这里是 r， 所以这一段叫 r d theta， 方向是 along theta direction。And then the length along this direction is a little bit complicated. You have to project your r onto the xy plane. And then calculate the length of this. Once you do this projection, the length here is equal to r sine theta. All right, and then this differential length right here is going in the direction of phi. So you pick up the differential angle d phi to give you r sine theta d phi. That is the differential length along phi direction. OK， 所以呢，你有第3个这个小长度是在这个方向上头，你必须先把 r 投影到这个面上头来，得到 r sin theta, and then multiply with the differential angle in this direction, that is d phi, to get this dl phi. Okay, so once you have the differential length along r theta phi direction, or same thing like a cylindrical coordinate system or rectangular coordinate system, then you can construct the small surface. For example, if you want to calculate the small surface, this one, you have two differential lengths. You simply multiply the two differential lengths together, right? Along this direction is r d theta. Along this direction is r sine theta d phi. So you multiply these two together to get this differential length. And the surface is along r direction, right? So you can construct DSR with two differential lengths. One is this one, that is dl theta, multiply with dl differential length, that's dl phi. Okay, and dl theta is understood to be r multiplied with d theta. And dl phi is understood to be this value, that's r sine theta d phi. Right, and the whole thing is along r direction. Okay, so you can really construct the three surfaces from this geometry. Again, you have all three surfaces. Then you can calculate the small volume right here. You can just pick up any of the three surfaces and multiply with the height of the volume. Okay, 所以呢，在这里头跟之前一样，你可以把它写成这个样子 ：DSR dot product with DLR is going to give you this volume. While you can also pick up the surface for ds theta dot product with dl theta to get the volume. No matter how you pick up the surface to start with, the volume does not change. Okay, 所以在这个r theta phi 的这个 coordinate system 里头，你也可以算出它的 vector dot product and vector cross product. Okay, so those are just tools for you to do calculation, but don't forget that the purpose for learning about this is that in electromagnetics you have to do a lot of volume integration, surface integration, and line integration because of the concept of the circulation and the flux. Okay, and also charge distribution and so on. 所以这是很快的一个三个坐标系的一个复习，有没有问题？对你们来说应该轻松愉快，来，都学过了。Any question? No? If not, let's go for a summary for this coordinate system. Well, you already see the similarities among all three coordinate systems. Then let's just put up a general form for that. Basically, in this three coordinate system, you have three unit vectors. They are perpendicular to each other. Let's call it u1, u2, u3. It can be x, y, z, r phi theta, or r theta phi or r phi z. 那在这个三个坐标系统里头，你永远都可以把它写这个一个 general vector 都可以把它写成这个样子 with three unit vectors and three magnitudes along the three directions. OK， 那所以呢，这个 AU1、AU2、AU3 在 XYZ coordinate system 就是 AX、AY、AZ， 在 Spherical Coordinate system 里头就是 A capital R、A theta、A phi. OK， now these three unit vectors are perpendicular to each other. Therefore, if you do cross product, you generate the third one from this cross product. And any dot product of the two, of any two, give you nothing because these three coordinate system, these three unit vectors are perpendicular to each other. Okay. 那我们来看这个 differential length 是表示成什么？我这 differential length 的话，可以表示成这个式子 dlu1, dlu2, dlu3. Okay, in XYZ coordinate system, dlu1 is dxax, right? dyay dzaz。那但是呢，在这个 cylindrical coordinate system 跟 spherical coordinate system 呢 ，you have to multiply the symbol with some matrix coefficient. Okay, and the matrix coefficient is defined to be like this: h1, h2, h3 in xyz coordinate system is very simple. It's 1, 1, 1. In cylindrical coordinate system, it's 1 for h1, 1 for h3, but for h2 is r because h2 that is phi 2是 phi， 这个一小段这一段呢 dl phi 是什么？是 r 乘上 d phi， 所以呢前面有一个 r 在这里。Okay, well same thing. You can check it against a spherical coordinate system. The matrix coefficient for spherical coordinate system is r capital R sin theta. OK， 那有了这个之后呢，你面积基本上就是每一个小面积就是两个小线段的 cross product。OK， 然后呢，小体积呢就是面跟小长度的 dot product。Okay, give you this result. So this is sort of a summary for the expressions in the three coordinate system. Okay, no question about it. 基本上就是很清楚的概念。Okay, now when we deal with when we want to calculate the circulation of some physical field, then we have to do line integration. Okay, a line integration is that you dot product the field together with the length. Well, don't forget the physical meaning of the dot product. The dot product tells you how parallel this F and L is, right? The dot product basically is a measure to tell you how parallel the two vectors are. So when you do line integration, 你基本上是要算这条线上这个物理量沿着这条线的效果有多强。Okay, so you use dot product. 因为沿着这条线上物理量有多强的话，基本上你在检查这个物理量沿着这条线的平行度有多大。Okay, this is the physical meaning of it. So you end up having cosine theta here. That is the angle. Theta is the angle between DL and F. Okay, and very often that we want to do a cross product, we want to do a circulation, to do a cross path integration, and this is called circulation. 尤其是在这个磁场的状况之下，你要做一个 circulation 的积分 ，cross path integration. Okay, and flux, another important concept in 电磁学. You want to do surface integration. You want to calculate how parallel this vector along the surface direction. So again, you use dot product. Okay, and again you have a cosine theta here. Be careful that when you do a surface integration, there's a direction for the surface, and there's a direction for the vector. Very often that you want to do a cross surface integration, then you put a circle right here to denote that you are doing the cross surface integration. 那你如果是做 cross path integration 的话，这里也要一个圈圈，告诉人家说你是做一个完整的圈圈的路径的 integration. Okay, so this is just establish some common language to communicate when you do the calculation. The direction of a cross surface is defined outward of volume. 一个 cross surface 其实就是包了一个体积在那个地方。这个体积呢，有内有外。OK， 从人角度上头来看，有内有外。OK， so the surface of the surface direction of a cross surface is that it's always point outward. 所以我如果有一个体积在这里，这个面的方向在哪里？永远都是朝外。OK， 就是大家先说好，这时候呢，你算出来的这个值呢，就有正跟负，然后呢，你可以赋予它这个物理意义。 So don't forget that the direction of a cross surface is defined outward a volume. Volume integration. Well, basically you have some density function. Integrate over some volume, give you volume integration. And this could be the easiest because it does not involve any vectors. 它不包含任何的这个方向在那个地方，所以这是一个密度的分布的式子，然后呢，你可以做一个 volume integration to get the total result. And very often that this is charge. So in space you have some charge distribution over some volume. If you do this integration, you end up having the total charge in space. Okay, 那这个经常会计算到。All right, any question? Very quick review. 但是这些呢，基本上应该都是你所熟悉的。下一次上课的时候呢，我们就开始介绍有一点点 vector calculus 的东西，那是 gradient, divergence, curl, divergence theorem, Stokes theorem, and so on. 所以在你离开之前，我给你做一个练习，是 Smith chart 的练习。